On June 9th and 10th, the Working Forest and Carbon event was held in Aitkin County, Minnesota. The event included a full-day workshop with speakers from throughout the United States and a field tour to explore land and forest management considerations for carbon storage. Speakers during the workshop include Mike DeBonis with the Forest Guild, based in Santa Fe, New Mexico. The Guild is a professional association for foresters and natural resource managers, and Mike addressed the forest management considerations for carbon sequestration. Dr. Jim Boyer of Dovetail Partners, a Minneapolis-based nonprofit providing environmental education, addressed the opportunities to recognize the carbon storage associated with long-lived wood products. Wood is half carbon by weight, and the use of wood products in long-term applications like housing can be part of a carbon sequestration effort. Mike Sayre with Great River Energy also spoke and addressed the perspectives of an energy producer and the current status of climate change and carbon policies. The workshop included presentations from two of the leading carbon standards and registries. Max Dubison spoke about the Climate Action Reserve and their approach to forest-based carbon offsets, including improved forest management protocols and the standards they use to evaluate projects, register credits, and track the sale of offsets. Nick Martin was on hand to represent the American Carbon Registry, addressing the approved methodologies for offset projects and improved forest management, while providing perspective on opportunities for Minnesota and the region related to land uses such as forestry and peatland areas. The final presentation of the workshop was an update from Mark Jacobs, the Aitkin County Land Commissioner, regarding the status of the Northwoods Carbon Credit Partnership that was initiated in 2008 to explore forest-based carbon offset opportunities for county land managers in northern Minnesota. The county has made progress in evaluating the possibilities, but barriers remain regarding feasibility of a project given the requirements of existing approved methodologies and the lack of a track record of forest carbon projects in the region. All of the presentations from the workshop are available at the workshop website, www.dovetailink.org/content/workingforestcarbon. After a day spent inside, the next morning the group headed out in the field to see forest management and carbon considerations on the ground. The first stop was a northern hardwood thinning. The forest management treatment in this unit provides an example of variable density thinning that focuses on providing more room for crop trees to grow and produce quality sawlog timber. The ecological classification system for the site identifies it as a mesic northern hardwood type, but toward the drier end of the gradient. Management for sawlog timber can be beneficial due to the higher potential value of these products. Also, from a carbon storage perspective, sawlog timbers are more likely to be used for long-lived wood products, such as building materials, flooring, or furniture, where the carbon in the wood remains stored throughout the useful life of the product. The management area includes 20 acres, where the basal area will be reduced from 114 square feet to 80 square feet, with the above-ground live tree carbon storage totaling 1,701 metric tons of carbon dioxide equivalent. Alternative management for the stand could have included more intensive harvesting or no harvesting, but both of these alternatives would have reduced the opportunities to produce quality sawlog timber on the site. The second stop of the tour was a decadent aspen spruce fir forest. The stand includes older trees and is experiencing high rates of mortality. The ecological classification system identifies the site as dry mesic conifer. The planned management includes a 37-acre treatment to reduce the basal area from 85 square feet to 19 square feet. The harvest will remove most of the trees, and therefore the stored carbon will be reduced to about 619 metric tons of above-ground carbon dioxide equivalent. Alternatives for this stand could include not harvesting, but that would have meant that the trees would continue to die and the future forest may transition to open shrubland or other cover types with less wildlife value than the proposed management that will favor dense natural forest cover with a mature pine component. Also, without management, carbon would continue to be released from the site as dead and dying trees decompose. A more intensive harvest would have removed additional carbon from the site and also limited the production of sawlog timbers in the future. The third stop of the tour was a young, 22-year-old aspen stand that includes conifer trees in the canopy. This site offers an example of tree stocking levels resulting from high-intensity regeneration harvests that include keeping all of the red and white pine. 16% of the original stand basal area was kept during the harvest. This site is a bit like how the forest seen in the second stop may turn out in the future. The forest classification system identifies both as dry mesic conifer. The 27-acre management unit at the third stop included reducing the basal area from 123 square feet to 20 square feet, with about 500 metric tons of above-ground carbon dioxide equivalent kept after harvest. Again, the option of no management on this site would have resulted in the older trees continuing to die and the carbon being released as they decay. More intensive management could have included harvesting the red and white pine and the removal of this additional carbon from the forest. The management treatment that was chosen helps balance goals for forest products with wildlife habitat objectives and carbon storage opportunities. The fourth and final stop of the tour was the thinning of an area of planted red pine. The management was done by working with the logger to select trees to be removed so that crop trees for sawlog timber would be given more room to grow. The ecological classification system identifies the area as a dry mesic conifer complex with some mesic mixed hardwood and wet mesic boreal hardwood conifer areas. It is a 70-acre unit that was thinned in 2009 by reducing the basal area from 167 square feet to 92 square feet, with over 5,000 metric tons of above-ground carbon dioxide equivalent remaining after the harvest. Alternatives for management of these trees could have included no harvest, which would have resulted in increased red pine mortality over time and reduced potential for sawlog timbers. The Working Forest and Carbon event offered the opportunity for land managers, landowners, and others interested in forest carbon considerations to learn about carbon markets and project protocols. The field tour helped illustrate how carbon considerations can be balanced within a range of management objectives and silviculture treatments. More information about the event, including presentations, are available online. Special thanks to the event sponsors and partners, including the Blandin Foundation, Aitkin County Land Department, Dovetail Partners, the Forest Guild, Great River Energy, American Carbon Registry, and the Climate Action Reserve.